GM, I just want to check. Can everyone hear me?
Yeah, I can hear you perfectly. Can you hear me?
Yes, I can hear you, Patrick.
Perfect.
All right, we're going to get started. Hi everyone. Welcome to the 11th episode of FX Cast. My name is Peng. I'm the marketing lead at FunctionX. So today we'll be chatting all about DPIN or decentralized physical infrastructure in Cosmos with Patrick from Jackal Protocol and Pete from Cudos. Welcome to the pod, guys.
Thank you very much for having us.
Yeah, no, thank you for having me. It's going to be an exciting one.
Yeah, I've been looking forward to this for the past few weeks since we launched the first DPIN episode. So to kick off, could you introduce yourself and your respective project?
Sure. Do you want me to jump in? So yeah, very nice to meet you, Peng. Thank you very much for having us here, and nice to see everyone joining the spaces today as well. So I'm Pete. I'm one of the founding team here at Cudos. So we're a blockchain built within the Cosmos ecosystem, and our focus is fully on providing scalable computing infrastructure to all of the dApps, the platforms, the protocols within the blockchain space.
And my name is Patrick. I'm the co-founder and CEO of Jackal Labs, where we built the Jackal protocol. At the end of the day, Jackal, unlike Kudos, so Kudos does compute. Jackal doesn't do math. So what we do is we do storage. So it's kind of like parking space in a weird way. At the end of the day, what we like to do is we like to deliver on-chain access to decentralized storage on any blockchain with a simple smart contract call. Our chain is a Cosmos L1, and the way that we kind of do distribution is via IBC, so that everyone has the functionality Jackal locally on any generic smart contract L1.
Awesome. And maybe for audiences who are not technical, maybe Kudos, Pete, could you start off by explaining what is decentralized cloud compute and how is that different from cloud storage? And Patrick, you can jump in later as well.
Yeah, absolutely. Yeah. Happy to take this away. So I think first of all is to say that, compute and storage go hand in hand, really. So, it's very important to have people need to store their data, and that's where, Patrick and his services come in with Jackal. But you also need the computing power to be able to execute, your kind of day-to-day tasks, whether that's running your metaverse or running some AI algorithm behind your DeepIn application, maybe even running a validator node. So there's lots of different use cases. All applications need computing power. So what we've done at Kudos is we've built a distributed network of computing power. So we have many different providers from around the world that are supplying computing resources into the network. So that's full stack. So that's GPUs, that's processing units, so CPUs, that's disk storage, and it's also memory. So if you wanted to come along and build a virtual machine or many virtual machines, then we've built that kind of interface that allows people to be able to do that in a very simplistic way, build out those environments as well. So this is kind of like on the path to decentralization. I wouldn't say Kudos Intercloud, which is our blockchain computing product, is fully decentralized yet. It's built on a distributed network because there's a lot of complications and stuff that we need to build towards or overcome first. But it's also kind of where the current market is and where we're seeing that demand is largely coming from companies and protocols that are running some kind of AI, and at present that needs to be kind of quite tightly clustered on there. So lots of different options, lots of different underlying kind of supplies into the network, which gives it that kind of decentralization from a vendor perspective. This is not all going into an AWS, so we're all going into Google Cloud, and that's what we wanted to get away from and provide something different to there. So that's kind of where our offering is there. Patrick, I'll kind of hand over to you before I consume all the time here on the spaces.
It's all good. Kind of like the way that we see blockchain rails is our backgrounds like forensics and digital investigations, and we kind of see blockchain as a way for us to have a really high security posture. along with a bunch of other benefits of kind of building a cloud environment on blockchain rails. We have in blockchain, we all kind of know that we have these specific unfair advantages compared to legacy systems, whether that's pricing power, sovereignty, ownership of data, having a low platform risk, being super efficient, being open source, resilient, just having a really, really high security posture by having self-custodial nature and on-chain permissions. Blockchains get rid of all the admin overhead, no centralized choke points of failure. And we have all these wonderful advantages, but the big advantage about blockchain technology and decentralized physical infrastructure networks in our brain is you have all these benefits, but the barriers and the moats that are kind of set up by the legacy systems, you have to have a lot of capex to compete. When I say capex, that's like the physical actual machines, right? If I wanted to go compete with Google, I need a few $1 billion to spin up a bunch of data centers. So what can we do knowing that we have all these unfair advantages? How can we leverage blockchain technology as an incentive layer to bootstrap all the servers in CapEx is kind of the way that we see it, right? Um, crowdsource bootstrapping and having these token incentives to incentivize everyday people to contribute to the public infrastructure around them is pretty special in my brain. Um, Essentially, it gives us a way for us to deliver all these unfair advantages and kind of sidestep the gigantic barrier to entry, being all the capital expenditure that you need to actually spin up all these machines. So it's kind of in my brain, I kind of look at it as DPIN gives us a bunch of benefits. Having blockchain rails, we all know the benefits of doing that, but the most important thing is bootstrapped CapEx is the big one, and when I like to think about it in my own way.
Yeah, I'm also curious, what compelled each of you to build your project? Did you encounter something in the web tool that you were very frustrated with and wanted to, which
Yeah,
made you want to do this?
I can tackle this one first, and then I'll kind of kick it back to you. But we come from digital forensics and investigations background. So what we were doing is we were investigating for law firms like flash phone attacks back in 2017 and all these different things, right? That being said, we didn't like blockchain when we first started working on it, but as we kind of got to understand the technology more and more, we saw a specific use case for an e-discovery tool for track and trace of digital evidence where you can use the blockchain as a permission system and do chain of custody from like evidence capture to the bench. So we built this project, we built it on Polygon. Then we were looking at the decentralized storage layer, and there was no way for us to kind of have the ability to maintain a really high security posture for a clean forensic environment. Um, where everything was kind of marketplace based, everything was really slow and kind of cold storage archiving of data, where it would like take 24 hours to get your files back. Everything was still like a proof of work blockchain, and there was no on-chain permissions. So one thing led to another, and we started building Jackal as a protocol just for our one use case. But then the underlying infrastructure that we were building actually got a lot more interesting and a lot more attention than the e-discovery tool that we were building in the first place. So that's kind of how I ended up in this position.
That's really fun. It's always fascinating hearing someone's backstory or a company's backstory on that. So yeah, I mean, I guess we had our own as well. The core of the team come from the data center and cloud industry. For since 2001 that business was being built. It was sold off in 2016, but it was during that time within the previous business that we were seeing all sorts of problems within the kind of cloud space, which was really just kicking off at the time, right? So that period between kind of 2010, 2014, 2015 was really when cloud was just starting to pick up in a very kind of similar position to kind of where blockchain was at that time, where the big enterprises weren't able to adopt the public cloud because their policies weren't in place, or whatever reason that may be. But we saw two really big kind of problems within that. And that was a lot of the smaller cloud service providers, that is those that have been around for many years, were losing market share to the big centralized players. So the AWS, Azure was coming in with from Microsoft, GCP from Google as well. And what was happening is they were losing the market share, and these big hyperscalers were driving the costs up and up and up and up. And what was happening on the other cloud service providers was that they were starting to have heavy underutilization during non-peak hours. But they were still always having to build out more compute for the peak hours of activity because people's computing needs are always increasing. So we wanted to find a way that we could help those cloud service providers monetize that idle capacity, be able to bring those revenue streams into them, and just create that kind of fairer cloud model where it's being distributed better. And then that kind of led us into thinking about, well, what if we were to do that with any connected device? So we're talking about PCs, consoles, mobile phones, whatever it's going to be. All of that has computing power, and the amount of computing power that required is just growing and growing and growing. So that's kind of where the vision of Cudo and then the Cudos blockchain, which we developed after, came from. Was how can we create that fairer economy, and also how can we look at how how we can clean this industry, because it's very electricity intensive, and some of that electricity, or a lot of that electricity, is being produced by dirty sources. So how can we make a more sustainable model? So a number of those milestones have been achieved. We actually delivered a proof of concept application right at the beginning that was able to tap into all of that end computing as well, but just purely based on where the market demand is at the moment and the way that people need to be able to consume compute. We've kind of focused very much on these kind of the more professional service provider environments, but remaining away from the AWS, the GCP, the Azure. So it's really about aggregating all of those smaller service providers around the world, predominantly as well within kind of renewable energy powered facilities, or sustainable powered, such as nuclear, gas flaring, etc. So we're able to kind of address those two problems that we saw in the last business at the same time. And the way that the kind of blockchain enables that, or helps that, is it just provides that way that we're able to kind of distribute the workloads out. And what will come in, it will be the kind of incentives. So as we get nearer towards the consumer edge, we call it. So as we start to develop and we're able to support the PC towers, the phones, as I mentioned before, then we'll be able to incentivize that with a kind of token-based system as well. So we're on that journey. We started off with the kind of more service provider environments to address that initial problem, and then we're building out towards that full vision.
Gotcha. And just to stay on you, Pete, could you explain what is Kudos Intercloud and how does it work?
Yeah, sure, absolutely. So, so Kudos Intercloud is the platform that you would go through via the Kudos blockchain to be able to access this scalable computing power. Now, one of the big benefits of blockchain, as Patrick has alluded to as well, is the kind of verification process, or the self-verification that it provides. So if you were to go into a normal cloud platform, you'd have to go through KYC, you'd have to attach a billing, a credit card or a debit card or a PayPal account or whatever the system that's in place on that. And all of that has to be verified before you can then spin up the virtual machines and go. It's not very Web3. It's not native to Web3 at all. So what we wanted to do was provide a platform where you could go in, you could connect your wallet. You'll be able to choose from a number of supported cryptocurrencies. So Kudos was the first that we supported, but we also now support USDC and USDT, and we'll be adding further native token support as well. And because that's already a verification of funds, because you've connected your wallet, you can then spin up the virtual machines and build out your environments in a permissionless way. So it doesn't need any other personal data on there in order for you to be able to spin up machines. So it's a lot more kind of inclusive, but importantly, it's a lot. It's native to the kind of way that Web3 developers want to consume their compute. So our ambitions is, of course, to increase that. So as we connect to more chains, And this is probably one of your questions coming up, so I won't go into it too much, but it's, that's predominantly the reason we built in the Cosmos to begin with, because of the interoperability. But we will also be going to kind of further multi-chain after that. And it's just about how can you lower the barrier to and simplify it from a user experience for all of these different developers within the blockchain space on all of these different blockchains with all of these different tokens, all of these different coins. It's like, instead of having to go in and to an exchange first, or and swap it out to get the currency that you then need to be able to use compute, it's like, how can we just support that straight up with the currency that is native to that blockchain developer, and allow them to quickly scale up their infrastructure environments to support their needs. So that's Cudos Intercloud. It's Cudos Intercloud is effectively the Web3 payment gateway and verification gateway to the underlying distributed network, which is Cudo Compute.
Gotcha. And for Patrick, could you explain how data is stored on Jackal?
Yeah, for sure. So the way that Jackal functions is we kind of have two peer-to-peer networks, which is interesting. So Jackal's not necessarily a marketplace; it's more a kind of like a SaaS application just baked into a Cosmos L1. So it's kind of a fixed price, but at the end of the day, that gives us a bunch of flexibility to do different things when it comes to how the data is stored. So on Jackal, let's say that I want to store a JPEG of something, right? I scroll up to Jackal, I go to the validators, I say, okay, validators, I want to open a storage account, so I'm going to pay $8 a month per terabyte for that storage account. I am going to tell them I want to take this file and I want to update my file tree, which is on chain, and I want to make sure that all the providers store 3x redundancy of it. That being said, once you tell the validators this is the terms of my storage, I'm going to have this, then the file is shot to a second peer-to-peer network, which is a distributed network of all of our 200 storage providers around the world. What happens then is the storage providers receive the file, and then they go to the blockchain and they prove to the validators that they continuously store the file throughout the duration of the storage period. So you can kind of think of it as the validators are kind of like the police of the system, and the storage providers are the workers of the system, where they submit attestations to the blockchain that they continue to have the file. All the data is kind of encrypted locally on the end user's machine, and then it uses the public and private key pairs to actually encrypt and decrypt the files, as well as manage the permissions of who has access to what data at what time. The cool thing about this is no one, not even the team that built Jackal, can access your data. The storage providers can't access your data. The validators can't access your data. The only person that can decrypt that file is the end user with their private key. So that's kind of like the story. You show up, you tell the validators, hey, I'm going to store this file. They say, okay, we're going to spin out these 3 storage deals. You send it to one provider, and then the provider submits those attestations. And then it's kind of interesting how Jackal does its redundancy and resiliency algorithms. Essentially, we guarantee that the file will always be stored 3 times on the network. In the event that one of the storage providers, let's say they unplug or a flood happens or something along these lines, the validator set will realize that that specific storage provider isn't submitting attestations of the file that it's supposed to be storing. After a certain amount of time, if the validators are saying, okay, this provider doesn't have that file anymore, that storage deal is automatically broken with our algorithms, and then it remakes a new deal with a new provider, and then that provider copies from the other 2 forms of redundancy. So it's kind of like an auto-healing storage network, and it's kind of like storage whack-a-mole in a weird way. But that's kind of how the story of the user story of how a file is uploaded and maintains on the network.
And in what scenario should a user use decentralized storage as compared to your regular Web2 centralized storage?
Yeah, so when we look at all of our partners that we have right now, everyone kind of has a different value proposition from the Jackal protocol. If you're a Web3 native user, the things that you might value is privacy, ownership, sovereignty. It's kind of like a return to sanity in a weird way, where in traditional cloud environments, what happens is you upload your file, and then now that cloud service provider has access to all your data. They can train on your data, they can sell your data, they can kick you off the network at any time. they can get hacked or things along these lines. And then that's kind of why we're in a cybersecurity crisis in the first place. So that's kind of the value proposition for the Web3 native user is ownership, sovereignty, on-chain availability. So you can kind of have smart contracts that interact with the storage layer. You can kind of have that ownership at your own personal level. And that's the value proposition for them. When we work with Web2 companies, whether that's like telecom companies for backups or board of directors that want kind of ransomware backups for mission critical data, they don't really care as much for the ownership and the decentralization factor. What they really like is the redundancy. So maintaining, you have this verifiable storage layer where always, no matter what, you'll have 3 times redundancy that's geo-distributed, and you have it at a killer price point, which is like $8 a month per terabyte compared to AWS, which would be around $200 a month per terabyte with 3 times redundancy if you start to include like the ingress and egress charges as well. So just kind of being like a modular, malleable storage layer, it's such a low level of the stack that a lot of people have different value propositions. It just really depends on who the end user is.
Gotcha. And same question for you, Pete. Like, why should users use a decentralized cloud compute solution as compared to your regular AWS or Google Cloud?
Yeah, I think it's a lot of the same reasons that Patrick has said. You know, it's an alternative, so it's going to depend on who the audience is, what they need to use it for. You know, a Web3 native is going to have a very different set of drivers to a typical Web2 user, as an example. But I mean, for if I was to look at if I just talk about kind of AWS, because everyone is familiar with that, and you know, all of the kind of hyperscalers fall into the same business model as an AWS. So you know, Google, Microsoft included within that, is that they have a lot of features within their platforms. It's designed to keep customers sticky within there. All the different levels of storage that they have as well, which Patrick kind of alluded to. But there's a lot of features in there that just a high percentage of the cloud users that are consuming infrastructure just do not need access to, but they're paying for it. And so, there's Kudos offers an alternative to that. We are out there saying we have infrastructure as a service. If you need high-speed GPUs, if you need CPUs for running, or general computing for running a validator, whatever that use case is, that's what we're providing you. We haven't got all of these kind of add-on services that you're ultimately paying for, even if you're not kind of selecting them, which is kind of where the hyperscalers really do kind of generate a lot of profit from. And I think so that's one piece of it. I think the other piece of it is really coming down to this kind of heavy concentration, this heavy centralization that those big hyperscale platforms have achieved. And they've achieved it very well. I mean, let's be fair and honest. They've achieved it very well, and over the last 2 decades. But what that means is if an AWS was to have a problem, let's say AWS Europe was to go offline because there was some issue with their regional data centers or because of their network or whatever it means that if you are on those computers within that ecosystem alone, then your services go offline. So the kind of benefit of having this kind of distributed network, which is what we've built, means that you have a level of redundancy, a level of resiliency that can't be met by a centralized cloud provider. And so that's another benefit. And then the third one is really if we go to the other side of things, because I've been talking about this more from a customer point of view, but the suppliers on our network in the background, this goes back to one of my answers earlier, that we're creating that kind of fairer cloud model where it's not, that whole market share is going to the hyperscale clouds. This is giving everyone a chance to be able to earn and benefit from being a supplier to the network. And that's really kind of where Deepin comes into its own. It's just giving people anywhere from around the world that opportunity to be part of the network and benefit from it.
Gotcha. And just to stay on you, Pete, within the decentralized cloud compute space, I think there are a few competitors. I think the most prominent one is Akash, who also in the Cosmos ecosystem. I'm just curious what's Kudos differentiation as compared to, for example, Akash?
Yeah, sure. And Akash have done a killer job. They've done really well. They're within the Cosmos ecosystem, as you said. So they're kind of our brethren in that respect as well. So kudos to them. No pun intended, or pun intended. But I think if you look at it from a kind of technical difference, because we are essentially providing cloud infrastructure, right? So the similarity is there. What Akash have done is that they have focused on if you okay, so let's think of this as a kind of a stack. So you have the hardware, you have the virtualization, and then you have containers. So virtualization running on top of that hardware, which is what we call bare metal in industry, containers running on top of the virtualization. We focused very much on those kind of bottom two layers, so on the bare metal and the virtualization. So that has its benefits in terms of the amount of control that you have over the infrastructure, as an example, the amount of performance you get out of that infrastructure, because you are taking out that kind of one layer at the top. It's got slightly higher performance, but it's going to, in some use cases, it's going to be better to run containers, which is what a cache specialize in. So it really, again, just comes back to that user and what you're looking to achieve, what you need to do, and how you need to build your environments will determine whether it's better for you to be able to deploy into bare metal or virtualize or virtual machines or into containers. So we differentiate in where what services we're providing at the layer of that kind of computing stack described.
Gotcha. And a similar question for you, Patrick. How does Jackal differentiate itself from, say, Filecoin or Arweave, who are also in
Yeah,
the decentralized storage
great
space?
question. Yeah, so when you look at kind of the competitive landscape of just storage providers in general, there's a few key differences. We can look at tech differences. We're like the only ones that are running on a proof of stake blockchain with hot storage speeds. Predominantly, when you look at Arweave and Filecoin, they're kind of like that monolithic proof of work stack where it's kind of more in like a cold storage or archiving of data where you put stuff to rest for a really long time, and it can take up to 24 hours to get your files back. Their approach to scalability is kind of like vertical scaling, where they start building like rollups on their own chain, where they kind of like have like AWS machines and they back up to the storage network. You can think of things like Lighthouse or Bundler in that sense. But at the end of the day, that's kind of like from the tech difference. That's it. The other thing is we can talk about it as a story. Let's say that I'm a builder, that I'm building a social application on Archway, for example. If I want decentralized storage that's interoperable with the chain, with my smart contracts directly, I have two options. Option number one is I use like a Microsoft Azure or AWS, and then I pin to IPFS that way. That's one option where you kind of like have this centralized choke point of failure for your storage. The other option, if I want to access decentralized storage, is I have to leave Archway. I have to pick up my app and I have to go build it on top of one of the monolithic storage L1s. This creates an issue where all the storage blockchains are competing against all the general purpose smart contract blockchains in a zero sum game for developers and users. Because they need developers, they need users, and L1s need developers, L1s need users, and they're fighting for those same pool of individuals. Jackal, we kind of look at distribution in a different way, and by kind of having a last mover's advantage, looking at the technology that's available to us, we were able to do Jackal in a way where we can provide value to other networks rather than try to fight them for their developers and their users. That being said, Jackal is the only interoperable storage layer where we can actually deploy smart contracts. We call them like our interchain outposts, or essentially just smart contract where we ported all of our blockchain modules into it, and we deploy them on every smart contract L1. That being said, that their users are our users and our users are their users, their developers are our developers are their developers, and we actually provide value rather than extract, which is interesting. This is kind of a different approach to distribution, and since we built on this tech stack, we have the ability to kind of deliver value rather than kind of fight them for their users, and making every blockchain a Filecoin or an Arweave, rather than kind of having our monolithic L1 that we need people to come to us rather than us come to them. And we think that the laws of physics are kind of in our favor in that way, where essentially Jackal can be available on every blockchain with a simple smart contract call at the end of the day.
Yeah, you just front run my question, Patrick. I was about to ask you about the Jackal outpost.
Yeah, well, at the end of the day, Jackal Outpost, it's we're like the first ones to do this, which is super exciting. And we've been working with the Interchain Foundation a ton on this concept of using IBC as a distribution protocol for something that's outside of finance, where essentially, like, we don't want builders and users to be on Jackal. Jackal's not a great place for liquidity. It's not a great place for building a community. It does one thing extremely well, and that's storage. That being said, leveraging IBC as a distribution model, everywhere IBC goes, Jackal goes, which is pretty fascinating at the end of the day. That means that every blockchain now has access to Jackal and all of its functionality with a simple smart contract call without any sacrifices. We're really excited about it, and we're excited what's going to come through this year as we start to deploy these outposts. We're starting with Archway. We got a grant to build an outpost there. Next one, we're in voting period for a ride chain where they want to use Jackal for vector databases, essentially, kind of like RAG frameworks, which is super cool. Outside of that, it's after that we can use Union to go to EVM. We can use Landslide to go to Avalanche. It's awesome. It's almost an unfair advantage when it comes to distribution, and we're super excited about it.
Yeah, I think a relevant question to follow up with is, why did you guys choose to build in Cosmos? And it seems like, Patrick, you kind of explained the benefits of building in Cosmos.
Yeah, like when we looked at Cosmos and we made the decision to build here in 2021, we were looking for the best place with the best tech stack where we could control the blockchain modules at their core. That being said, like if we wanted to build Jackal on Ethereum, for example, we couldn't do a lot of the features and the value propositions that we have today because we can't alter the Ethereum blockchain. Having the ability to build your purpose-built application, specific blockchain, without sacrificing interoperability, it was kind of a no-brainer for us. Not to mention the other beauties of building with the Cosmos SDK is everything's completely modular. If we wanted to, let's say down the road, it kind of just, you build an application that is built to last and designed to evolve using this tech stack. If we one day we wake up, we say, you know what, we don't like Tendermint consensus anymore. We like Narwhal and Tusk with what they're building on those Move blockchains, for example. In theory, we could rip out Tendermint, jam in Narwhal and Tusk, and away we go. It would be a pain in the ass. It would be a lot of work to do something like that, but it's something we can do, and we have sovereignty over the tech stack, and we have awesome validator set, and we couldn't be happier with our tech stack decisions.
Yeah, I'm going to immediately follow up with that and say exactly the same reasons. So, 2021, we were looking at this ourselves as well. And I mean, okay, so same reasons that Patrick explained around the kind of modularity, what the Cosmos SDK gives you is a bunch of Lego bricks that are already there. And yes, there needs to be some kind of customization, but it saves a long time on the kind of development of building everything totally up from scratch. But it still gives you the flexibility to be able to move things out, move things in to kind of customize it as things evolve, right? Because this is a fast evolving space. And there's lots of technologies, lots of Lego bricks, if you like, that haven't been built yet that will be around the corner. To add on to it, we were looking at what are we actually looking to achieve? What is the job that we're looking to get done? And if we are going to build this globally distributed, large, scalable kind of compute infrastructure network that all of these blockchains are going to be able, the developers will be able to access, then we need something that's going to be able to support microtransactions at micro costs as well. That automatically rules out Ethereum for the reasons that I think everyone on this spaces will know. The gas fees are kind of prohibitive to being able to do that. And there wasn't the kind of all the layer 2 solutions that are out at that time that there is now as well. Cosmos does that very well. It's been very stable since the beginning, as well as everyone can see. But I think we were also placing our bets on IBC, so that's the Inter-Blockchain Communication Protocol. And we're, although that hadn't been launched yet, we were looking kind of out to the future. We need to be interoperable with as many chains as possible to make our life easier for when we are connecting to these blockchains to be able to provide them with access to this computing power. So initially, IBC within the Cosmos ecosystem gives us access to however many chains are IBC integrated there. But what we've seen recently is IBC is being tested outside of the Cosmos ecosystem as well. So Near Protocol, even Ethereum has tested it successfully. So that kind of bet is kind of playing off. We're seeing that kind of IBC becoming that standard outside of the ecosystem as well, and it just fuses all of those the kind of blockchain ecosystems together, and ultimately makes our life a little bit easier. So yeah, those were the predominant reasons behind Cosmos. I think just one further thing to add on that is it's just a very developer focused, developer friendly community as well. So we kind of instantly felt within that kind of Cosmos family from the start, even before we'd started building, with access to kind of teams, developers, advisors, within the interchain, within the Cosmos hub, and other protocols as well. So it just had a kind of nice feeling towards it. On top of the tech.
There's one other thing that I want to mention that's really important about picking a tech stack. If you look at kind of DePIN networks in general, these are really, really complex, multi-dimensional protocols. There's components of sometimes multiple peer-to-peer networks. There's multiple machines. Other DePIN guys are doing stuff with IoT sensors, cameras, robotics. It combines software, hardware, and all these different dimensions. If you look at kind of an NFT marketplace, for example, it's a singular dimension. It's you build the app, you deploy the app, and away you go. Not anything against NFT marketplaces, but it's kind of like the difference between building like a deep tech biotech company and building an application like Snapchat. They both can be equally as profitable, but one is just fundamentally way harder than the other. When you have like this multi-dimensional protocol involved, you kind of run into the situation where like DePINs haven't been the flavor of the month for years, because it takes a long time to develop these things before you even get a taste of product market fit. Obviously, the harder things create the most value, and there's a lot more upside with building hard things, but the amount of risk involved with building these things is enormous. That being said, when we look at like risk frameworks and you're choosing a tech stack based on risk, the last thing that I want when I have all of these multidimensional parts of the stack, you need like 5 things to work in harmony for you to even have like an MVP. I don't want to be waiting for another team to have to ship a chain upgrade for us to have our product work. We have too many risks to begin with, and having a third risk where I have to wait for the Solana team to ship an upgrade for me to have a feature in my product, or I need Ethereum to ship an upgrade in 4 years for let's say like account abstraction or something along those lines. That's not something that we can wait for. You might run out of runway. You have so many risks to begin with, and kind of reducing that risk where you have sovereignty at the tech stack level and at the chain level is really, really, really important for us when we were choosing a tech stack in the first place.
Yeah, very, very well said. And just 2 more questions to wrap up our conversation here. What are some misconceptions that you would like to address when it comes to decentralized compute and storage? Maybe Patrick, you could go first.
Yeah, the big one is kind of speeds is something that I think is silly with the tech that we have today. Obviously, traditionally, a lot of the storage networks are slow, and they're monolithic, and they have long block times and things like that. Jackal has like a comparable hot storage layer, which is pretty fascinating. It's almost on par with Google Cloud on a speed front. It's going to be a little bit slower, but that's because like we bake in encryption that bloats the files, and having larger files means that it's going to be a little bit slower. But a lot of like the feeling of slowness on kind of like this new age of storage layers is more of like a UX problem and just like kind of portraying what's happening to the user. It's very, very similar if you look from a speed perspective, which is pretty fascinating. I think that's kind of like the performance is something that I think is a big misconception when it comes to blockchain storage layers for this new age of storage networks.
Yeah, I would agree with that with compute as well. I think really to turn that question around, it's more where is the kind of products market at the moment for full decentralized cloud compute. So if I kind of remove the storage part from the equation, because kind of Patrick's already answered that, but if I look at the kind of use cases that are out there, it's a very, very, very different type of use case that would be using a fully decentralized computer network, i.e., going back to where I mentioned the PCs and the consoles and electric vehicles and maybe even smart fridges in the future if it could tap into some of that kind of IoT devices. Is a very, very different type of use case that would need that type of computing, or that would be able to use that type of computing to execute their needs, compared to where we're seeing huge demand at the moment in terms of training models for AI, inference for AI, kind of video rendering, Unreal Engine 5 kind of servers, etc. All of that stuff that I've just mentioned needs that kind of performance. It needs the high bandwidth. It needs security. It needs service levels to make sure that it's up and running as close to 100% of the time as possible. And that kind of rules out those end devices, those consumer edge devices. When we start talking about maybe simulations, some big scientific research data that needs to be executed, it doesn't need to have any local storage per se, so it can run, just using the kind of CPU cycles, doesn't have any latency requirements. So that's kind of the speed between the end user and the machine that job is being executed on. All of those kind of those factors come in. Then yes, there is a way for a fully decentralized network to be able to support that. So it's from our perspective, that is absolutely the utopia, right? We want to be able to support all types of use cases and very much kind of have that fully decentralized compute network was managed by the code. It's able, anyone in the world is able to connect any single device and automatically paid via token from the smart contract itself. But it's something that we need to work towards. So I think the misconception at the moment is there are many or a few, should I say, players within this space that are building towards the fully decentralized cloud compute, but it's just not where the market demand of the product fit is today, which is where we kind of started off as distributed, and we'll build towards that.
Gotcha. And for the final question, could you share with us what's on your roadmap for the rest of 2024?
Yeah, how long have you got? It's pretty lengthy. Yeah, I'll go quickly. I'll just kind of summarize it and hand over to Patrick. So yeah, I mean, for us this year, it's all about just continually expanding out the audience size that we can reach. So to do that is connecting to more chains within the Cosmos ecosystem, but also taking it multi-chain outside of the Cosmos ecosystem as well. And that's just really coming through the kind of native support for the tokens that are native to those chains. So we can be able to, to add value into those ecosystems. There's other things as well. We're going to be adding kind of software templates for generative AI and other partnerships that we're building with popular service providers out there, software service providers. This is to make it easier for people to be able to spin up the infrastructure that's already got that software installed. So all of that's happening as we speak. We're seeing integrations that are happening already, and the Cudos into cloud, revenue is that's being generated on that is increasing rapidly. So we've been really pleased with the progress so far. But there's integrations that we've announced, like the ones with DStack that are providing ML ops services, and that automatically deploys to infrastructure in the background, and we're one of those infrastructure providers. We're doing one with a set of ETH whales at the moment, which they've. It's amazing how quickly they've developed a platform, and we'll be announcing that in the coming weeks. But again, that's all around kind of infrastructure for spinning up AI and coming from the kind of blockchain space as well. So yeah, so watch this space, but for us, it's more chains, bigger audience, adding value to those ecosystems.
Yeah, for us, it's really just the outposts, and it's we're working on like retrieval augmented generation vector databases, which is pretty cool as well for some kind of like AI use cases as well. Outside of that, like we have big upgrade coming in Q2, which is like our V2 upgrade and our V2 economics upgrade, which kind of turns Jackal more into the real yield land. Outside of that, it's we have our data agents that's going to be coming towards the end of the year. So smart contracts can read and write to off-chain data. So it's kind of like a weird data availability type product where you can have smart contracts that are doing that are editing files, which is pretty cool. Last thing is kind of towards Q4. It's desktop prototypes and kind of having a better user experience is a big focus of ours. But that's kind of like the short list. We have a lengthy blog on our website about everything that we're working on in 2024 as well. If anyone really wants to nerd out on that.
Awesome. Yeah, and with that, we've come to the end of today's episode. Thank you, Pete. Thank you, Patrick.
Very welcome.
I really appreciate you having me. Thank you.
Yeah, and for our listeners, we hope this has been informative. Thank you all for listening, and we hope to see you at the next FX Cast. Bye bye.
Thank you. Bye bye.